Welcome back. In this session we are going to learn how to write queries that are in the form of simple regular grammars in order to produce concordances. So you have already opened the text. I remind you, File, Open Text. You should get the portrait of a lady. And then in the menu Text, you're going to click Text Locate to get this window. And in this window, you're going to type in chair and then choose a colored button, for example red. And Nudge is going to compute the concordance of all the occurrences of the word chair, the word form chair. So here, Nudge tells us that there are 47 occurrences of chair in the text. You can double click on any line to get in the text. You can click on after or before to sort according to the right or the left context. You can modify also the length of the left or right context. So before we start to write complicated grammars, I need to speak a little bit about grammars. So basically a natural language contains an infinite set of sentences. So the problem is how to describe this infinite set. So Chomsky and Schutzenberger designed a mathematical tool to describe languages. They are called generative grammars. There are 4 types of generative grammars: regular grammars, context-free grammars, context-sensitive grammars, and unrestricted grammars. Regular grammars are the least powerful. Unrestricted grammars are the most powerful. So in terms of regular grammars are equivalent to type 3 generative grammars. Regular grammars are the least powerful types of grammars, but they are very useful in linguistics, in particularly to describe some simple morphological operations, phenomena. In computer systems, there are lots of computer tools to understand regular grammars, such as awk, grep, lex, perl, sed, etc. There are also linguistic tools that are better adapted to describe morphological phenomena in natural languages. The most famous one is XFST, which was a tool developed at Xerox PARC. So in Nudge, how do you write regular grammars? So we already know that chair is a query. It's a regular grammar by itself, but it will only find the occurrences of the word form chair. So if we want to recognize also all the occurrences of the word table, we want basically to write a grammar that will recognize both chair and table. This operator is called disjunction, and you type it in Nudge with the pipe character here. So if you type chair, pipe, table, and then Nudge will locate, will recognize, will find all the occurrences of the word chair, but also of the word table. So this is the first operator in regular grammars. The second operator in regular grammars is called the concatenation. So for example, you want to recognize a sequence of words such as his followed by chair. So how you write it? Basically, you just type in his space chair, and this will recognize all the occurrences of his followed by the occurrences of chair, his chair basically. So this is pretty simple and obvious for English, but understand that the concatenation operator is actually a very important operator. So for example, there are some languages where there is no space character in text, for example Chinese. If you want to find a blue table in Chinese, you will still write a grammar in which you will use the space character to tell Nudge that that's table followed by blue table, blues followed by table. In the grammar, you will still have to put the space character. So that's the second operator. Now we have 2 operators, so we need to know which operator has priority over which. So first of all, let's see this, for example. If I type in Okay, so we have two operators, concatenation and disjunction. So we need to know which operator has priority over which operator. Particularly, if we write something like his chair, pipe, table, what does Nuge do exactly? Well, concatenation has priority over disjunction, which means that Nuge will look for all the occurrences of the sequence his chair, and then it will look for all the occurrences of the word table. So this is different from this. Here, Nuge will look for all the occurrences of his followed by chair or table. So if I type in his, opening parenthesis, chair, pipe, table, closing parenthesis, it will find his chair and his table. So as we saw, we can use the parentheses to fight, I would say, the default priority. We can also use it to factorize some expressions, some grammars. For example, instead of typing in his chair, pipe, his table, we can factorize this expression by writing his followed by opening parentheses, chair or table. So this is the left factorization. We have the same phenomenon to the right. So if we have his chair, or pipe, her chair, we can write this by saying his or her followed by chair. So this is left and right factorization, and we can of course combine both of them. So we could write, for example, her or his in parentheses followed by chair or table. And this is what we're going to get. I think here we find some expression, his chair, her chair. We would find also her table, his table. So this was the fourth fact about regular grammars. The fifth one, the fifth important functionality of regular grammars is a neutral element. So there is a neutral element for the concatenation. Usually in linguistics and in mathematics, it's written epsilon. Computer scientists speak about the empty string or empty word, and sometimes in computer programming languages you write them by entering double quote, double quote. In Nuge we will write it opening bracket, uppercase E, closing bracket. So what does it mean for this element to be neutral for the concatenation? It means that if you take any word and you say that the word is followed by epsilon, by the empty word, the result is the word. So basically it's an empty word, means it doesn't add anything. Epsilon is the empty suffix. And it's also neutral to the left, so epsilon, the neutral element, the empty string, followed by word, is the same as the word. So there are many linguistic applications about the neutral element, the empty word. For example, in English, we can say that S is a plural suffix. If you have a word such as table and you concatenate it with the suffix S, you get tables. Yes, but then what is the suffix for singular? Well, we will say that table followed by epsilon, by the empty word, is table. So we would say that in English, epsilon, the empty word, is the suffix for singular. And we are going to see also that that's going to be very useful. Every time we want to say that a linguistic unit is optional, basically we're going to say that this linguistic unit, we want this linguistic unit or epsilon or the word, the empty word. For example, what does this expression mean? It means that I'm looking for the word followed by little or nothing, which means that the word little is optional, followed by table. So in order to get that, I need to explain a little bit. It's a little math manipulation. So let's say, for example, I want to look in the text for all the occurrences of the sequence a lady, but also I want to have or to get all the occurrences of a young lady. So I could write this, right? A lady, pipe, a young lady. Now, if I factorize to the left, so here I factorize a, see a here and a here, so I can write a followed by lady or young lady. But you see, inside these parentheses, I have twice the word lady, so I can also factorize to the right. So this gets a followed by nothing followed by lady or young lady. I can do that because lady is equal to epsilon lady. Epsilon lady, epsilon followed by lady is the same as lady. But now I can factorize because I can see that lady is here and here. So I write inside this parenthesis, epsilon lady pipe young lady is the same as epsilon or young followed by lady. And now I have a little, this parenthesis is useless. You can keep it, but you don't need to. So the resulting expression is a followed by young or nothing, young or empty word, followed by lady. So what we just saw here is that instead of writing a young lady or a lady, we can notice that the word young is actually optional in this grammar. Therefore, we can write it young with a disjunction operator with the pipe epsilon. So young or epsilon is a linguistic way to say that the word young is optional. So every time you find a linguistic unit that's optional, whatever it is, could be a phrase, it could be a sentence, it could be an adjective or even an adverb. The way to write a grammar about it, to describe this, is to put this element in disjunction with the empty word. So let's say I just typed here, a followed by young or epsilon followed by lady. And as you can see, I got 36 occurrences, a lady, a young lady, a lady, a young lady, etc. Okay. Now the last operator we need in order to write regular grammars is the Kleene operator. So what is the Kleene operator doing? Well, let's say I want to be able to find the sequence a pretty table, but between a and pretty, I can have as many adverb very as I want. I want to recognize a pretty table, but also a very pretty table, a very, very pretty table, and why not a very, 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 very pretty table. Unlimited number of occurrences of the word very, including zero, including no occurrence of the word very. So this is exactly the Kleene operator. The way to write it is to use the star here. So a very star pretty table means a followed by any number including 0, 1, 2, 3, 17, 234 occurrences of the word very, followed by pretty, followed by table. Again, this operator is very important in linguistics. So for example, let's say I want to describe all the declarative sentences in English. So I could write something like, I want a subject followed by a verb followed by any number of complements, including 0. So for example, this grammar would recognize Joe slept, you see, Joe subject, slept the verb, but then no complement. Or Joe ate an apple. Or why not, Joe gave Mary an apple. Or Joe gave Mary an apple in the train yesterday, etc. So this grammar is typically saying that I have a subject, a verb, and then any number of complement. Another useful use of the Kleene operator. Let's say I want to find in a text all the occurrences of a verb conjugated in the present perfect. So what I would write is I want the verb to have, followed by an indefinite number of adverbs, could be 0, could be 1, 2, 3, followed by a verb in the past participle. So I would write something like the verb to have, followed by any number of adverbs, followed by a past participle. And this would recognize things, sequences such as it has never before done a Beckett play. So here is an example of the star of the Clini operator. I'm looking for the word the. So WF is a special code, a special symbol in Nuge that means any word form. So WF star means any sequence of word forms followed by lady. So basically I'm going to look for the followed by any sequence of word forms followed by lady. So it will find the portrait of a lady, the young lady. Why not? The expression apply more particularly to the young lady, or the doorway of this apartment was presently occupied by the lady. There is no limit on the number of word forms. Yeah. So in order to recap a little bit, so how to build regular grammars in Nuge? Well, you can write a word such as chair. You can also write a disjunction, let's say chair followed by a chair or table, to get all the occurrences of chair and also all the occurrences of table. You can have a concatenation, so a word followed by a word, in order to write to describe sequences of words. Is followed by chair, for example. You have a priority between concatenation and disjunction. The concatenation has priority over the disjunction. So if I write his chair, pipe, table, Nuge will first look for his chair. So you see the concatenation has priority. And after it will consider the pipe, the disjunction, and it will find just table. And this is different from his chair or his table. You can factorize. You can use left factorization, right factorization, or even combine them. For example, his chair or his table is the same as his followed by chair or table. And we have the empty string, empty word, epsilon. So table followed by epsilon is the same as table. And then we have the Clini operator. For example, a very star pretty house will recognize all the sequences that are constituted by the word a, followed by any number of the word very, followed by pretty, followed by house. So maybe let's have a little exercise. So let's say I want to find all the occurrences of the verb to come, followed by back, down, in, or over. So I suggest you pause this video, and then I will give you the answer. So pause the video. Okay, so an answer could be, for example, opening parenthesis, came, or come, or comes, or coming, followed by back, down, in, or over. And if you type in this expression in Nuge, or here it's Web Nuge, the same, you click on Apply Query, and you will find coming down, came back, came in, come down, etc. 158 occurrences. So here is the end of the queries of the grammar, regular grammars that you can build with Nuge, simple regular grammars. So congratulations, you now know how to write simple queries, basically simple regular grammars, and to apply them to text or a corpus. That would be exactly the same. Text locate, here you would say corpus locate, and then to get a concordance.